blocks of metal, okay? And we started off with the definition. We started off with what is an element, what is what? A mixture, what is an atom, and all that. We are aware of those terminologies, right? And we also gave an example if we are given different pictures. How to identify an element, an atom, a compound, a mixture, and what else? And then a molecule. Yes. So today we'll talk about the periodic table. Okay? Today we'll talk about what we call the periodic table. But before we get into details about the periodic table, we are going to start off with what we call the atomic structure. Okay? This is what we are going to start off with. We are going to start off with what we call an atomic structure. Okay? If you look in your book, you have a periodic table, right? You have a periodic table that has so many elements. You have about 100 elements. Now, each of those elements has its own structure, just like how you are. Okay? If I ask you right now, what is your structure? What would you say? What are your structures? What did you tell me? Yes, Nkono? What are your structures? Even your physical structures. You don't know your physical structures? No. It's an example, Structure. I want you to understand what structure means. If I ask you what are your physical structure, what would you say? Head. You have a head, okay, and what is attached to the head? Head. You have head that is attached to the head. What else is attached to the head? You have eyes that are attached to the head. Yes, Junior, what else is attached to the head? You have ears that are attached to the head, the nose, and all that, and also your mouth. That is the structure. Similar to an atomic structure, This atomic structure will show you where each particle is supposed to be, okay? Where you find particles such as protons, particles such as neutrons, particles such as electrons, But before we get into the structure, let's go through the discovery of the atomic structure, okay? Because scientists were trying to figure out how are we surviving, okay? How are we surviving from breathing whatever it is that we are breathing, okay? For people did not just wake up one day and decided, oh, we are breathing oxygen. No. They had to discover one by one. What is it that we are breathing in? Okay, it's oxygen. But oxygen is made up of what? How is it we are able to breathe in oxygen but our lungs are not exploding? You know that oxygen is very explosive? Yes, oxygen is explosive. It causes what? Combustion. It causes burning. Okay? But it's balanced out by nitrogen in the air. Okay? So the first man to discover an atom was Mr. If you have a textbook, this Solid Foundation textbook, go to page 57. The first man to discover just a particle, okay? He just discovered a particle, His name was Mr. John Dalton, okay? That was Mr. John Dalton. Mr. John Dalton just discovered a sphere. That's what he discovered. He just discovered a sphere. That if we are breathing in, we are probably just breathing in a particle, which is a cycle. It's just a sphere. Okay? He's trying to discover the structure of what we are breathing in. He discovered that, okay, it's just a sphere. It's just a particle that we are breathing in, but that particle is just a sphere. Okay? That was his discovery. But then another gentleman called Mr. J.J. Thomson discovered that sphere is not just a sphere, it's a sphere that has charges, or it's a sphere that has particles in. Okay? He discovered that sphere must have positive charges. Okay? Because remember, everything is charged. Even you that are seated there, you have charges around your body. Okay? That was the discovery of Mr. J.J. Thomson. He discovered that, okay, we do have a sphere, but within that sphere, there are charges. The positive charges and the negative charges, just in that sphere. Now you discovered that this is oxygen that we are breathing in, but that oxygen has positive charges and negative charges. Okay? And then another gentleman named Mr. Ernest Rutherford discovered that, okay, you are right that we do have a sphere, and that sphere has positive and negative charges, but then this sphere has, the charges are separated. In a sense that the positive charges are the ones in the middle, okay? The positive charges are the ones in the middle, and the negative charges are surrounding the sphere, okay? The sphere is the circle, eh? That was Mr. Ernest Rutherford discovery. That we do have a sphere that has charges, but the positive charges are in the center, while the negative charges are surrounding a sphere. Okay? That was his discovery. Another scientist said, okay, I agree with you. We do have a sphere. The sphere does have charges. Those charges are separated where you have the positive in the middle and the negative surrounding the sphere. But this sphere also has what we call a nucleus. Okay? In the nucleus, that is where you will find the positive charges. Okay? He said now, that sphere is not just a circle, an empty circle. Okay? It's a cycle that has a nucleus, but within that nucleus, there is what we call positive charges, and they are called protons. Okay? That was his discovery. And then he also discovered that these negative charges, they are no more together in one space with the positive charges. The negative charges are around what we call shells. Okay? This is where you will find the negative charges. The negative charges are not anymore within the sphere. They are around a shell, and that shell is covering a nucleus. Okay? That was his discovery. So Mr. Niels Bohr discovered what we call shells, or what we call orbits. It's the same thing, eh? Orbits, okay? And then around the shell, you have what we call a nucleus. Okay? Within the nucleus, we have the positive charges. Okay? We have positive charges, but those positive charges are called what? Protons. Okay? And then we also have negative, we also have shells that have electrons, but those electrons are called electrons, they are negatively charged. Okay? We also have electrons, and those electrons are negatively charged. Yeah? That was Mr. Niels Bohr discovery. Niels Bohr is now the famous scientist that we know. Okay? Niels Bohr. Niels Bohr. Even if you go to university, this structure is called a Niels Bohr, or it's called a Bohr structure. Okay? This one is called a Bohr structure. It's named after the person that discovered it. Yeah? Are we together? So that was Niels Bohr's discovery. But then again, another scientist said, okay, Mr. Niels Bohr, you are very much correct. An atom or the particle has a nucleus, okay? Because it's just not a sphere anymore. You see how it was evolving? First, the discovery was just a sphere, okay? The discovery was just a sphere that is nothing. It's just like a cycle. It's like a ball. Yeah? It's like a ball that has nothing inside. And then scientists continue discovering that ball has charges. It has positive and negative charges. Another discovery, those charges are no more together like this. Those charges are separated. The positive charges are in the middle, and the negative charges are the ones that are surrounding this space, the ball. Another discovery, the charges are present, but the positive charges are in what we call a nucleus, okay? And the negative charges are the ones that we call the negative charges are around what we call a shell or an orbit. Okay? And then they discovered that these electrons, the negative charges that we have found in the second discovery, they are called electrons and they are around the shell. While the positive charges are inside what we call a nucleus and they are positively charged. Okay? And then that's when people were thinking, okay, we have an atomic structure that is up to date. Okay, so come in. That's when people thought, okay, the atomic structure is complete. James Chadwick discovered that no, inside the nucleus, we just don't have positive charges. We must have another particle that is neutral. Neutral means it doesn't have charges. It's not negatively charged, it's not positively charged. Okay? Chadwick discovered that within the nucleus, we have what we call a neutral atom, a particle, okay, that is neutral. It's not positively charged, it's not negatively charged, it's just a neutral particle within the atomic structure. And then up to date, even now, that is the structure we use, okay? Until now. Because the final discovery was made in what? 1932. It was so far along, okay? 1932 was the final discovery. Then now, the atomic structure has what we call shells. Around those shells, there is electrons that are negatively charged. And within the shells, we have what we call a nucleus. And again, within the nucleus, we have what we call positive charges, which are the protons. And we have the neutrons. Okay? So when you are drawing an atomic structure of any element, this is how it should look like. Now let's go to our periodic table quickly. And let's try to spot oxygen. Okay? Let's try to spot oxygen. Okay? So now, if you spot oxygen there, oxygen has what? Has 16 and it has 8. Okay? Each atom or each element, we call them element, is an atom or it can be an element. Okay? Can we all look at our periodic table? Let's look at oxygen. Oxygen has 8 and it has 16. Okay? This number that is up, am I correct? 16 is up, eh? No. This number, the bigger number, okay, of every element is called the mass number.
Yes.
Yes.
In the textbook.
Is the other way around that? Yeah. No, the one in the textbook is not correct. It's supposed to be the mass number that is up and the small number, which is the atomic number. Or you can say the proton number. Okay? The one that is down here. The one in the textbook is not correct. That's why I gave you those ones. These ones are the ones that I told you to paste in your book, yeah? Those ones are the ones that are correct. Okay? So, you have an atom of oxygen. It has a mass number of 16, and it has the atomic number of 8. So, if you look at this structure, where do we place our atomic number? If you look at this structure from the discovery, where do you put that atomic number? If we were to draw the atomic structure of oxygen. Is it on the shelf?
In the middle.
No. In the middle, and what is that middle called?
The nucleus.
And?
Sphere.
In the sphere, but within the sphere there is also what we call what?
A nucleus.
A nucleus. Okay? It's a nucleus. This is a nucleus. That is where we put the proton number. And this is the proton number. So when you are drawing the atomic structure, when you are drawing the atomic structure, you start off with the nucleus. I like to draw it as a small sphere. It's a nucleus. Because the nucleus is very small. Okay? It's a nucleus. Within the nucleus now, you have what we call proton. Okay? P. Letter P represents proton. And we are saying the proton number of oxygen is what? is 8. You put 8 there. Okay? What was discovered in the nucleus again from Chadwick? What did Chadwick discover? A neutron. Okay? Chadwick also discovered a neutron that is found in the nucleus. So when you are drawing the nucleus, you should indicate the proton number and you should also indicate the neutron number. Now, letter N, capital N, represents neutron. And how do we find that neutron? We find that neutron when we find the difference between these two numbers. Yeah? The neutron, this one that is still in the nucleus, is neutral. It's called a neutron. The particle that is neutral, is a neutron. And how do you find a neutron? You find the difference between these two numbers. Meaning you minus 8 from 16. This is how you find the neutron number of every element. Okay? All together. If I ask you to find the neutron number of any element, you are finding the difference between the mass number and the atomic number. Okay? So if you minus 8 from 16, you are getting what? You are getting 8. So that is the neutron number there. So you are done with the nucleus. Okay? And then now, since we are drawing the atomic structure, what else should be contained in the atomic structure? Because we only drew what? The nucleus. What is after the nucleus? The shell. This shell that contains what? The negative electron. Okay? So first, there is a rule that says that the first shell that is after the nucleus, because this is the nucleus, this is our nucleus. This shell that is after the nucleus is only supposed to be occupied by a maximum of 2 electrons. Okay? And where are you drawing those number of electrons? You are drawing this number of protons. Okay? The number of protons equals to the number of electrons. Okay? Are we together? The number of electrons that you are drawing on the shell equals to the number of protons. So if you have 8 protons, it means you have 8 what? Electrons. So those electrons are the ones you are drawing on the atomic structure. But then you are starting off with the first shell that is only supposed to have how many electrons? Only 2. So you write or you draw 2 electrons there. The electrons can be illustrated with an X or they can be illustrated with a dot. Yeah? Are we together? Okay. So if you draw 2 electrons, you took 2 electrons from A and you draw them there. How many electrons do you have that are remaining? You will have 6 electrons that are remaining. Eh? So it means what? You have to draw another what?
Another shell.
You have to draw another shell. You have to draw another shell that will now be occupied by how many electrons? By 6. Okay? The rule that says the first shell should be occupied by 2 electrons says also that the last shell should be occupied by 8 electrons. But you cannot draw 8 electrons if your proton number is only having a specific number of electrons. Eh? Because now we only have 6 electrons. We don't need to draw 8 because we are drawing this number of protons. Are we together? So here we are drawing how many? 6 electrons. 3, 4, 5, 6. Okay? And like this, we are done with the atomic structure of oxygen. Yes, Aleta? Yes.
I got confused at the first shell.
What's the first? The first, this one? Yes.
You please explain. I do not understand when you say only 2 or how many.
Okay. This is the first shell that is after the nucleus. It's like a level. Each atomic structure has levels. Okay? You see, let's think about the solar system. Eh? You have Mars, you have Jupiter, you have whatever. Are they not in an orbit? They are circling in an orbit. Eh? Each of those orbits have their own energy. So, the first shell has an energy in a sense that it's only supposed to be occupied by 2 electrons. So every atomic structure that you are drawing only has 2 electrons. Okay? Even if you draw an atomic structure of nitrogen, it will start off with 2 electrons. Even if you draw the atomic structure of carbon, it will have 2 electrons. This shell, the circle, the first circle after the nucleus is the first shell. Okay, it's the first shell, and it's only supposed to be occupied by 2 electrons. Okay, and then the second shell is supposed to be occupied by 8 electrons, given that you have more protons to place on this atomic structure. But since here we were only remaining with 6 electrons, we are just going to draw those 6 electrons that are remaining on the last shell. But if we are dealing with an atom that has a bigger proton number, we'll draw 8 until we finish the number of electrons. We'll look at an example now. Okay? So this one here is the second shell that has a maximum, it's supposed to have a maximum of 8 electrons. But are we getting the basic way on how to draw the atomic structure? I'm expecting to see a nucleus. I'm expecting to see proton number and neutron number within the nucleus. I'm expecting to see the first shell that has 2 electrons. I'm expecting to see the last shell with the appropriate number of electrons. Yes, that's all. There is no way you have an atom that does not have a mass number. Observe your periodic table very well. The transitional metals. No, your syllabus is not expecting you to go until then. But they all have. What are you saying? Oh, these are what? Radioactive elements. They don't. But no, this is. You are drawing we don't draw the mass number. We draw the atomic number. The atomic number is the smallest number. I'm not going to ask you to draw an atomic structure. You are never asked to draw an atomic structure when you are using the big number, which is the mass number. Okay? But again, these are radioactive elements, meaning they have a very small mass. Their mass is very small, but not measured. They are like very, 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 very small. That's why their mass numbers are not together. Okay? Are we together? Let's look at an example of what? Another example. Which example should we look at? To draw the atomic structure of that element. No. Calcium. Okay. Carbon dioxide. Is it an element? If you say carbon dioxide, remember, go back to those terminologies that we talked about first. You have an atom, you have a compound, you have a mixture, you have a molecule. Carbon dioxide is what? If you go back to those terminologies, carbon dioxide is what? We forgot our terminology. It's a molecule, it's a compound. We are talking of an element, an atom. Okay? So who said calcium? Okay, let's try calcium. The chemical formula of calcium is what? No, chemical formula. You see those letters that are written there? CAMGBELI. CA. Those are the chemical symbols. Okay? So if I say chemical symbol, you are giving me those letters there. Okay? So for calcium is capital C with small letter A. Like that you are talking of calcium. Okay? So calcium has what is the mass number of calcium? 14. And what is the proton number of calcium? 20. Is 20. Okay. We start off again. What do we start off with? You draw what? The nucleus. You draw the nucleus, just a dot. And then you have a line that is pointing out. This line is going to indicate what? P. What is P? The proton number. What is the proton number of calcium? 20. Okay? The proton number is the same as what? Atomic number, and it's this small number, So if you see for calcium, the 20 is there and it's smaller than 40. Okay? So you have proton numbers that are 20. And then you have the neutron number. How do we find the neutron number? Subtracting the difference. The difference between what? The mass number and the proton number. So if you take 20 from 40, what will you remain with? 20. Yeah, remaining with 20. Okay? And then after the nucleus, what do we draw? Next? The first shell. And the first shell is only supposed to be occupied by how many electrons? 2. So you draw your 2 electrons there. 1, 2. Okay? So if we draw 2 electrons, how many more electrons should we draw? If we only draw 2 electrons from that proton number there, how many more electrons should we draw? 18 more. We should draw 18 more electrons. But then, now you are drawing what? The second shell. Now the second shell can be occupied by how many electrons? By 8. Okay? Now here you can put 8 electrons. As much as you have 18, you don't put all of them 18 there. You just put a maximum of 8. Okay? So you put 1, 2, 3, 4, 5, 6, 7, 8. Okay? In total now you have how many electrons that you have drawn? You have 10. You have only drawn 10 electrons. So meaning how many more electrons should you draw? 10. Another 10. So what does that mean? Another shell. Okay? And if you end up having the third shell, this third shell is still occupied only by a maximum of 8 electrons. Are we together? So you draw another 8 electrons on that shell. 4, 5, 6, 7, 8. Now how many electrons do you have in total there? 18. So how many more do you have to draw? 2. So meaning we still have to draw what? Another shell. And that shell will only now be occupied by how many electrons? 2. Only by 2 electrons. And you draw them there. And if you count all these electrons, these dots, they will always end up to 20. Are we together? So that is how you draw the atomic structure. It guides you. Yes, Aleta? Oh, okay. It guides you. The atomic structure, the structure is to guide you how the electrons are arranged in each shell. Okay? Let's quickly do a class exercise there. Where is your clock? Let's quickly do the class exercise quickly. Class exercise number 1. Draw an atomic structure of magnesium. Let's just first draw this one. Let's just draw first the atomic structure of magnesium using your periodic table. Your periodic table is very much useful. It's the one that will guide you on how many protons you have and the mass number. You don't really focus on the mass number, okay? You don't focus on the mass number, you focus on the what? On the proton or the what we call the atomic number. Okay, so let's quickly draw the atomic structure of magnesium. Yes? Huh? You want a book? Share with Junior. There's a very table here. Okay. We quickly do that one. should have how many, a maximum of how many electrons? The first shell. The first shell should have a maximum of how many electrons? No, the first shell there. Those two dots after the nucleus is how many electrons? It's 2, eh? Okay, what else was that?
But my pencil is not.
It's written on the floor. Okay? Why are some painting in? But what is happening there? Okay, the nucleus. But why is this number all the way here? Right there. Okay, well? Are you sure the total number is 20? No. Which one are you looking at? Magnesium. Not manganate? Did you look at manganate? You're looking at manganate, eh? Magnesium is this one. This is manganate. We are looking at that one. So this is wrong. Magnesium, the names are there. The names are there. They should guide you which element you should use. Let me have your pen. Total. Okay, 2 electrons. And then the next shell should be occupied by how many? Maximum of how many electrons? 8. Are these 8? No. So if you can, how many more here? Have another one. They should be 8. They should not be scattered around like this. They should be 8. And then you have another shell until all those electrons are done. Yes. Okay. Okay. Your electrons should be on your shell. You should not be floating there. Who else is done this time? Okay. Yes, I am. Yes. Okay. Good? Yes? Paulina is also done? Okay, good. Let me see. No? Agatha, no? No? Okay, let me see. Okay, good. Okay. Okay, you should indicate the proton numbers and neutron numbers close to the nucleus, eh? Close to the nucleus. The thing is 12, eh? And let's count all these things together. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? 11, 12, 13, 14. And having 14. But the thing we have proton numbers. But when you even have P and P, you have proton numbers and neutron numbers. And if you are saying it's 12, why do you have 14? Okay? Okay. Good. Yes. Who else? Okay. Okay. Good. But where are the proton numbers and where are the neutron numbers? Yeah. Okay. Good. Okay. Let's look at the structure. Yes. Let's do correction together now. Admire. 12, eh? They go and look in your book, you're saying 12. Let's count.
But why is the first shell having 4?
How many electrons did I say should be the maximum electron in the first shell? 2. Why do you have 4 there? And what did I say that the second shell should have a maximum of how many? I said the second shell should have a maximum of how many? Thank you. So far. Okay. Let's do corrections. Joseph. Okay, Joseph will be the last one. Okay, let me see. The second shell only has 2, 4, 6. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No. The electron should be 18 to the second one. There should be 8. So you're supposed to add 1 there and 1 there. Then the other 2. Okay, let's quickly do the correction. Let's do the correction. Eh? We are done. Let's see if we are having the correct one. Okay? We have magnesium. Chemical symbol of magnesium, if you look in your periodic table, is what? Mg. What is the number that is down there? 12. And 12 is the number we look at. Eh? We are looking at 12. We are drawing the atomic structure using this number 12. Okay? So now, what is the first thing that you draw? You are drawing your protons and neutrons, but they are far from the structure. Okay? They should be close. So if you don't want to draw the stick, you can just draw a big circle like that to indicate, and inside you put P that will have how many electrons? I mean how many protons of magnesium? Is 12. And you can draw